This is the first experiment, electronic components. In a previous session, I am talking about passive components. There are six passive components like a resistor, capacitor, inductor, switches, relays, transformer, connectors, number of cables you have to use in an electronic component. These all are the passive components. And after that, we will learn the active component, BJT and the MOSFET. BJT and the MOSFET, it is a active components. In a virtual laboratory, here the virtual laboratory, go to the IIT Kharagpur virtual lab. It's right click on that, click on right click, then open a new tab. This is the virtual laboratory. In a virtual laboratory, IIT Kharagpur home page is open. In this page, number of laboratories available here. We can choose directly basic electronics lab. Click on that, open a new tab, and here the welcome message is display on basic electronics virtual laboratory. Then after that, click list of the experiments. This is the list of experiment. You can see in a previous session, familiarization with resistor and familiarization with capacitor. These two components already done on that previous session. Today we will learn the familiarization with inductor. The experiment number 3, familiarization with conductor. Inductor, you click on that. This is the inductor. You can see the inductor, it's a function. Before starting on this is the number of function wall. This type of the wall you can use inductor. Then what is meant by inductor? And it's a function. Inductors can use a function of controlling the wall or controlling the electrical current or the electrical charge in a device. That here you can use according to the wall. Its wall controlling the fluid like water, gas, any type of the liquid you can control, and that is through the pipe. This is similar for the resistor. You can see, find out the color coding is the orange, brown, and the gold. You can find out the color for the particular resistor. This is similar for the inductor, and the can use for the controlling the amount of the current flow through the conductor. This is the conductor flowing the resistor. This type of the conductor is also used in a controlling the current. Inductor, why it is used inductor in electronic devices? Because it is used as controlling the current. Controlling the current. You can see here the first experiment in a laboratory. Experiment number 1. Name and name. What is the name of the first experiment? Study of active and passive components. Study active and passive components. This is the titles of the experiment. After that, in this you can write down your roll number, your name, and the particular batch is mentioning up. You can click on the printout pages after submission of the first experiment. If the completed first experiment, we will get the printout. Then here AM to study different active components. Active and the passive components, there are different active and passive components like a resistor, capacitor, inductor, devices such as the diode, MOSFET, BJT, and IC, and here switch and the relay. These all are the passive and the active components. We will learn some passive components as well as active components. In a passive component like a resistor, capacitor, inductor, but where resistor is a current limiting device. Here the capacitor you can use store the charge. Then inductors he can use for the controlling the current. Resistor it limits the current. The inductor is controlling the current. Transformer we use for the iron core in step down transformer and the step up transformer. These two types, the transformer it is used to transferring the electric charge. Then conductors you can use for the conducting flow of the current through the connectors or the cables. Then point number 6, switches. Switches you can use for the switch, electric switch like a on off switch, toggle switch. If the switch is on, then the connectors current will flow through the connectors. And point number 7, this is the diode, BJT and the MOSFET. All are the active device. He can use all point number 1 to point number 6, resistor, capacitor, inductor, transformer, connectors and the switches. All 6 passive components will help to the pin point number 7 in a active devices, because it's a electronic circuitry. It's the most important part for the all passive components for flowing through current, and that is required to active device. It is diode as a switch. He can controlling the resistor through the limiting of the diode. Then next BJT, it's a bipolar junction transistor. In a BJT, bipolar junction transistor, the bipolar junction transistor BJT we can use for the resistor, connectors and the switches, because BJT it's a one type of the switch. Then MOSFET we can use for the resistor, capacitor, connectors and the switches. And the various ICs, these ICs you can require all components. In a diode as a rectifier, it is a rectifier we can use for the resistor, capacitor, transformer, connectors and the switches. All the passive components will help to the active components or the active devices, that is means of the BJT, diode, MOSFET and the various ICs package. You can see here the apparatus. Apparatus is most important. Apparatus is equipment or the required equipments required for performing the practical. We can performing the practical study of active component and the passive component. If the required of multimeter, in a digital multimeter, analog multimeter, we can perform the resistor, capacitor values, but the digital multimeter we can performing all the passive components as well as active components. It's the values of resistor and the capacitor. Its typical value we can show on digital multimeter. Also we can find out the voltage, current for directly get the through the multiplier. In CRO cathode ray oscilloscope. In a cathode ray oscilloscope, it is used for displaying the output in a screen like a sinusoidal wave to the function generator. Function generator, it is the input device we can use for the sine wave, square wave, triangular wave, ramp, spike, all the functions we can use a function generator as the inputs, and the output will display through the CRO. Here the theory of active components. The active components we can use for the actively electrical device or the electronics device. We produce a signal through the amplification, amplify the signal and it produce a gain. That's why active components is most probably used for the electrical and electronic circuitry. Then passive components you can see the all passive components is generating doesn't require source on energy. In a passive component, it does not require source energy, but it performs intended functions, but it is a performance intended function. It can be also used for the receive energy which it dissipate or absorb, like some examples resistor absorb. In a resistor we can use for the receiver energy, like a receive energy through the current, and it's a resistor we can use for the limits of the controlling the current. Then capacitor inductor, this is also passive component. You can see in the detail passive component. The resistor, this is already done in a previous practical. Resistor, it is a physical material you can use for the length. Resistor, physical material of the flow of electric current through the insulator. Because it is the insulator, we can use a non-conductive material. Then that's why the current is flowing through the resistor. It is much a active device, because electronic circuits you can use a active device. Hello, student, you can understand what's going on?
Ma'am.
Okay.
Yes, ma'am.
The resistance of material with the length of L and A. The resistance of material, you can find out the L is the length and A is the area. Area is directly proportional to the length because of the resistivity. This is the rho. Is small p is meaning of rho. Rho, R-O-W, rho is the resistivity. Resistivity into length divided by area. That's why the R resistance material. Resistance material, you can find out the area. Area. This is the resistor. How much area? It's only 1 meter or the 0.5 meter. That's why it's require a very less area. Then find out the length. Length is large because of the resistance conducting through the conductors. That's why length is increases and area is decreases for the resistor. Then it's a wire of the resistor required the tolerance. Tolerance is required 0.1% or the 0.1% or to 5%. 0.1% it's a particular resistor, but you can use for the color coding. According to the color coding, the tolerance it must only gold color or silver color. That's why while selecting the resistor flowing of points, it is to consider stability, tolerance, temperature coefficient of the range, power rating, maximum power voltage, reliability, change of resistance value with frequency, load life, environmental condition and its weight, and value, size, shape. All these specification you can see. This is the resistor specification. Stability, it is a stable because you can find out the color and it's a fixed value. Then after that the tolerance is must only gold and silver color. Temperature coefficient of the resistance. Temperature coefficients, minimum temperatures is required because it's only passive components. It is not an active components flowing the current. If it helps to the active components flowing through the current. Then power rating, this is very less because of the power is directly proportional to the current. Then operating voltage, it is a maximum operating voltage required greater than 15 volt, 20 volt, because the resistance is used for the circuitry. Reliability, it is reliable. Then the resistance value with the frequency, you can change on the frequency like a 1 hertz, 2 hertz, 5 hertz, 100 kilohertz. According to the inputs is connected through the function generator. You can increase the frequency according to the resistance. It's change the value through the frequency. Its life is a condition because environmental condition in a node. This is the node of conductor. Some students you have putting on that conductor current of the coil. It's drop. Then we will change the resistor value, size and shape. It is depends on the material. These all are the resistor. You can see on the rheostat, normal resistor, trimmer, variable resistor, fixed resistor. These all are the types already done in a previous session. That's why I'm not detailing the ceramic capacitor, metal, carbon film resistor, metal film resistor, and it's here mentioning it is a values of the specification for each and every resistor. In a wire wound resistor, you can see the wire wound resistor for wounding, or it's a good stability to the conducting resistivity. That's why resistance is used in a wire wound. Here the specification, you can see the range of value in a ohm. Temperature is -5 ppm degree Celsius. Stability is greater than 0.05%. These all are the smallest value because it's a high power handling capacity to required small size. Voltage is greater than, because it's a less than 300 volts. The resistor is working in proper way. Then last one, variable resistor. This is the variable resistor, carbon potentiometer, wire wound potentiometer, singleton wire wound potentiometer, and multimeter potentiometer. We can use for the X-ray tube voltage, current, and high power application. Next, capacitor. Capacitor is inversely proportional through the charge because of it store the electrical current. Then directly proportional to the these types of the dielectric properties like unpolarized property or the polarized. Unpolarized like oil, paper, mica, glass. These all are the unpolarized. But the polarized you can use for the electrolytic capacitor, plastic film, wear vacuum. These all are the electrical polarized capacitors. Then ceramic capacitor, you can see on that. I'm going fast about this because of first two experiments in already performed in a virtual laboratory, resistor and capacitor. Today's we going through directly inductor. What is mean by inductor? Inductor, it's the elements to store a magnetic field and the electric field. In a magnetic field, its field is changing the current according to the electromotive force. In a electromotive force, the magnitude is proportional to the rate of change of the voltage, rate of change of the current. That's why the inductor is most important part in a passive component. Is the length, voltage is equal to length into rate of change of, or the derivative is inversely proportional to the length. This is the symbol of inductor. You can see. Then after that, look of this. This is the inductor. Iron coil is rotating in particular plastic coating material. These are the types. Fixed resistor we can use for the RLC circuits. Then variable inductors we can use for the electronics, electrical circuits. Their air, iron core and ferrite core. Air core and iron core and ferrite core we can use for the transformer for transferring the values through the transferring the current through the coil. Then next parameter, transformer. Transformer you can see it is a electrical energy one form through the another form. Means primary winding through the current is flowing through the circuitry. Here applying the voltage. If the iron core is charged, then the current is flowing through the primary winding to secondary winding. That is here number of turns. The number of turns is equal to number of coils. This is number of coils. You can see the N, and the derivative of the charge is the phi magnetic permittivity. It's a phi d by dt. It's the north. V of S is the secondary. Voltage is equal to N is the number of turns in a and the phi by magnetic flux divided by dt. It is generating a magnetic field is increased, then electromotive force is also increased. And here you can see the equation V of S is V of S secondary voltage divided by the primary voltage. This is the input is equal to number of turns secondary divided by number of turns primary. It is the ratio of two equations in the form of secondary voltage and the primary voltage. These all are the types. This type of the transformer you can use for the audio. This is the type of the transformer you can use for the electrical and the electronic circuit boards. You can use for the mounted equipment transformer. And this is 12 volt or the 15 volt chassis mounted equipment transformer. You can use for your project like a 50 hertz operation on this all transformer. Then distribution transformer. The distribution transformer are generally used in electrical power dissipation and transmission system. These all are the types: distribution transformer, power transformer, control transformer, auto transformer. These all are the theories. You go through that because of I am not detail in first experiment because it is a study experiment, not practically perform on the transformer or the, but it's a diode in a rectified circuit. That's why it's performing in a transformer circuitry. Then isolation transformer, instrument potential transformer, instrument current transformer, all are the types, but maximally in electronics as well as electrical circuits only step down transformer. If the applications you can perform in a radio frequency or any type of the radar, that's why you can use for the step up transformer. Only these two transformer you can use in a electrical and electronic circuits because it's operated in a high voltage, high frequency performance. That's why this type of the transformer is used in electrical electronic circuitry. Then types of the connectors. These are the electrical connectors like a audio video connector, BNC connector. This is audio video. This type of the connector you can see on the sound or TV connections. In a backside, you can see on your power connectors through the TV, LED TV, LCD TV, or the Sony Philips sounds you can use for the connector. This type of the connector is the industrial power connectors. Also, we can use a central processing unit, monitors, printers. That type of the application you can use for the power connector. Then RF connector, this type of the RF connector, like a radio frequency checkers or the signal to generate in a multi-gigahertz or the high frequency, like 100 megahertz, 500 megahertz, or the tera megahertz. That type of the frequency we can use for the coaxial cable through the BNC connector, like a shared standard type of the connector BNC, bidirectional network connectors, LC, and the N connector. All are networking connectors through the radio frequency. Then next one, the switches. These is also passive components. All are going to the passive components. Only diode, BJT, and the MOSFET, it is a active components. Then switch, you can see on the switch, it's flow the charging or the course to the prototype model. Prototype model means small mini projects or the final year project you can implement for the 3000 or the 5000. In that between you can use for the low voltage, like a 5-volt supply you can given on that and perform the applications. That type of the switches you can use for the push up button, rotary switch, toggle switch, slide switch. This is the slide switch, you can shift on left or right. This type of the switches you can use for the IC packaging. This is the base dual in DIP, dual in package. And dynamometer plugger you can use for the dynamites for the particular electrical powers or the switch. A switch is a device changing source. It is also prototypical model to the mechanical device. For the example, railroad switch. Railroad, this type of the dynamic plugger you can use for the rail. Then the switch is typically electrical power and it's a telecommunications circuit. All are the electrical or the electronic devices we can use for the controlling through the switches. If the switch is on, then the circuitry flow the current. Then electrical switch, toggle, rocker, push button, contacts arrangement. It is if the contact arrangement, if the contact of the switch, then this type of the switch, this is the contact switch. Single pole, single throw. This type of the switches you can use for the relays. If the contact of the switch is the single switch, for the single pole, single throw. One type it is touch in the bottom of the another slider, then you can use supply the current. And if the open, then no, because the break. Then double DPST, double pole, double throw. If the upper side throw is single wave, touch, not touch, touch, not touch, is the toggle type of the switches relays to the double pole, double throw. Double pole, double throw. Then next one, diode, BJT, MOSFET, and the various IC package in active components. Before starting the active devices, student, you can understand all passive devices like a resistor, capacitor, inductor, connectors, transformer, switches.
Yes, ma'am.
Okay, this is the first
ma'am.
experiment. It is a theoretically experiment, but it's most important you see the component symbol and its structure. That's why in experiment number 2, you know that the resistor, how to find out the resistor. In a capacitor, how to find out the capacitor and its a calculation. You can see on that next experiment. In this experiment, only identify the components in active components and well as passive components. You can see the diode. Diode, it is a two terminal device, but it's flowing the current only one direction, because one type of this is also one type of the switches. If the diode is closed switch, then the current is flowing, the switch is on, and if the reverse bias switch is off, because it is a infinite Z voltage, it is a open switch. The types of the diode you can see: PN junction diode and the Zener diode, LED, photodiode, these all are the diodes. Here the polarity and the symbol, you can see the polarities. Then PN junction diode, it is a two terminal device, but it's a one junction formation. If the electrons is moving left side of the p region and combine with the holes, it's generated positive charge in n region, and if holes is moving through the p region, holes is moving to the n region and combine with electrons. That's why it's a formation of junction. If the formation of junctions, all the electrons and the holes is combined through the recombination of junction, and it increases the barrier potential voltage of 0 volt, 0.0 volt, 0.1 volt, 0.2 volt, 0.3 volt. According to the barrier potential, voltage is required to conduct the diode 0.7 volt, and that after that the diode is conducted after 0.7 volt. This is the conduction state in a voltage. It is a period of the VI characteristics. Still diode will conduct after the voltages in a barrier potential. This is the barrier potential is required through the current. In a barrier potential, voltage is increases, the current is also increases, and the diode it goes to forward bias, it is a conduction state. But it is a reverse bias, it's not conduction because of the diode, it's a reverse bias, it is a open switch. That's why it's breakdown voltage after a 0.7 volt, minus 0.7 volt, diode goes to reversed bias, and it's a breaking a voltage. Here theoretically you can know on that all these things. It's a breakdown region. Next one, Zener diode. You can see the symbol. It's similar to the diode, PN junction diode, but it's only you can use for the symbol. It's some changes. If the diode goes to forward bias, it's a conduction state, Zener is on. But Zener is also reverse bias, it is also on, because it's operated only reverse direction. It is operated in reverse bias condition. You can see here, if the voltage is increases in Zener diode, it's increasing state in forward bias. But the Zener diode, it's basically ordinary. You can use a PN junction diode, but normally operated in reverse bias. But it is operated in reverse bias, not forward bias, because it's a Zener current, Zener voltage current. Where the Zener voltage current? But ordinary PN junction diode is connected reverse bias condition, is not use a Zener diode practically. Zener diode is practically it's defined high doped PN junction diode. It's a reverse bias, it goes high dopely, heavily doped. Heavily doped, doping process is largest because it's a PN junction. Is the formation of PN junction in a reverse bias. Maximum electrons is maximum electrons in the formation of junction. Maximum electrons is moving through the p region, and it's created a negative charge. That's why it's heavily processing PN junction diode in reversed bias. and its concept is known as Zener reverse voltage. Zener reverse voltage or Zener voltage V of Z. You can find out the normally operating range. This is directly proportional to the Zener diode or avalanche breakdown voltage. If the above diagram you can see, when the diode is connected in a forward bias, diode acts as a normal, but its reverse bias, the voltage is greater than Zener voltage. If it is a forward bias, is conducting in normal PN junction diode, but it's a reverse bias if the Zener diode, it's reverse bias, all in supply. Here the supply in circuitry reverse bias, and diode is also operated in reverse bias. That's why here maximum Zener voltage is created and Zener is goes to reverse breakdown voltage. And the current is increases very rapidly in the Zener diode. Current is increases here. Zener current is increases, the Zener voltage is also increases. Then third one, applications. Applications, it is used as a switch, and maximum it is as a switch in a Zener diode. It is a voltage regulated power supply. Voltage regulator power supply. Then next active device, another active device, BJT, bipolar junction transistor. This bipolar junction transistor, we can use a 3-terminal devices like a base, collector and the emitter. The arrow it indicates through the emitter in downwards, that is meaning of NPN transistor, and arrow is upward through the emitter, that is meaning of PNP transistor. If the NPN transistor, its maximum majority carrier charge in negative in the form of anerogen, and the PNP maximum majority carrier charge in a P region, that is created a hole in a positive charge. That's why it is a 3-terminal device and the 2-junction formation. Then why use for the BJT? It is a semiconductor device, 3-terminal semiconductor device, but its junction, it consists of 2 PN junction. 2 PN junction, one is the hole and one another is the electron. 2 PN junction, which is applied or able to amplify or modify the signal. If the amplify the signal, then voltage is increases and diode goes to forward bias in first PN junction. Junction is the base to collector junction. The signal is forward bias, and another base to emitter junction is the another junction. The maximum amplification will possible in forward bias of base to emitter terminal, and another amplification will possible in base to collector junction. That's why maximum voltage is created in a 3-terminal transistor, and transistor it's used for the amplify the signal. It is a current control device. Current control device because of is controlling the current. This is the circuits in NPN BJT. Here the plus minus in a theoretically part already covered on that. This is the base is common, means this configuration is known as the CB common base configuration. What is the configuration? Configuration input sources, you have to connect it a positive first junction base to emitter junction, and another is the output voltage you can measuring in the base to collector. This is another junction base to collector junction, here base to emitter junction. If the started of NPN transistor, in a NPN transistor we can see apply here voltage is applying, then current is moving after the formation. Here formation of junctions. Which formation of junctions? Because this is the NPN, then majority carrier of these junctions only electrons. In emitter terminal is heavily doped and that's why it's a heavily doped transistor. You can use a VCE, collector emitter terminal, and it's operated in a P region. P region is created a negative charge, and the N region is created a positive charge. That's why maximum voltage will provide in amplification. Here you can see if the current, emitter current is negative in a NPN, because I is equal to IB plus IC. This is the sum of the base current and the collector current. Because the alpha amplification factor in NPN, alpha is equal to collector current divided by emitter current. And here the junctions of base to emitter junction, base to collector junction, base to collector emitter voltages. You can find out the voltages and current in NPN transistor. Similar, it is downwards in PNP transistor. Only voltage is the emitter and VCB. Here, difference between PNP. In a PNP, it's a majority carrier in holes, and in NPN, it's majority carrier in electron. The maximum doping process as compared to PNP, electrons is majority carrier doping process in silicon material. That's why here the I is positive, IBIC is negatively charged, and the other voltages you can find out that the collector PNP transistor. Here the applications, there are two applications. One is the switch and another is the amplifier. Amplifier is the applications we can use for the operational amplifier as a transistor. It's amplify the signal only. You can see the loudspeaker. If the sound is minimized, then output is minimized. If the sound is increases, according to I am using a headphones, I am speaking very loudly, then you can see learn very loudly. I am speak very small. Yes, students, you can understand. This is the signal is very less, and I am speak very loudly. Students, you can understand. Then if the voltage is increases, then amplifications is increases. If the voltage is decreases, amplifications is automatically decreases. That's why transistor it is operated a amplifier signal. Then next, MOSFET, it is reverse of BJT. BJT is a current control device. It is a voltage control device. MOSFET you can use only control the voltage. It is three terminal device. Okay. Drain, source and gate. BJT, base, emitter, collector. Here the structure in a laboratory you can see this is the MOSFET 8408, and theoretically you can see this is the symbol if the gate terminal is connected to the drain, if the drain voltage as the VCC and the source is connected to the ground, and this signal you can use for the field effect metal oxide semiconductor transistor, metal oxide semiconductor field effect transistor, MOSFET. This type of the transistor you can use for the fabricated or control oxidation silicon. Gates is cover the voltage and conductivity through the device. It is ability to change the conductivity. This is ability to change the conductivity with the amount of applied voltage can be used amplify or switching the electronic circuit. This is the ability to change the conductivity. But in a BJT, this is not change in conductivity. You have to flow the current through the emitter, then emitter you can flow the current. But the MOSFET you can use for the change the conductivity. If the maximum source you can provide that through the drain terminal, its ability you have to change the voltage. According to the gate terminal, it's the maximum voltage. You can provide only terminal of gate and drain. You can change the voltages according to the amplified circuit. This is also two types. One is the N channel, like electrons MOSFET, and the P type, it's a P channel, it's a holes MOSFET. If the N channel, you can use region between source to terminal, and in a P channel, it's current through the negatively, because it's after the formation of the junction. P channel, its whole positive charge, it's created a negative charge, and the N channel region, already first it's electrons created a negative charge and junction is formation, then it is created a positive charge. Here the formation of junction in a depletion region, here gate terminal, here VDC, voltage across the drain terminal to the source terminal. Source is ground, drain, and the gate. And here the B point is the substrate for the depletion region. You can use for here the P layer, P some holes, and here maximum electrons. That's why you can changing the voltage through the conductivity. In instead of positive voltage, we apply negative voltage, and whole channel will be formed to oxidation layer. Here the oxidation layer, SiO2 layer, is the formation in the form of N channel. Here similar for the P channel, drain is connected to the P. P plus is the oxidation, SiO2, silicon oxide is the generation to the P channel. And the terminal you can use for the source, gate, and drain. If the negative gate voltage is applied, the all holes attracts to the P source, and the drain region into the N channel is apply the P region. P region is connected to the drain, and some P regions holes is connected to the source. The source is connected to ground, and the drain is connected to VCC. That's why maximum hole majority carrier charge is associated in the form of donor atoms. Donor means donate some atoms, and in N channel it's accept the all electrons. That's why it's accepting. This is the reverse of the N channel and the P channel MOSFET. Is you know on that the semiconductor devices, N type material or the P type material. In N type material, it donates the atom. Donates the atom means it's sharing some atoms for one silicon to another silicon, and that here created a pentavalent impurity in N channel. And in a P channel, it's accepting all atoms, like it's creating a trivalent impurities. Trivalent is the 3 atoms you have to generating a one silicon material, and in a pentavalent it donates 5 atoms or 5 electrons to donate another atoms. That's why N channel material, its maximum electrons is maximum 3 electrons in a valence band. This already covered in a semiconductor devices theory. You go through that, and then you can learn the N channel and the P channel in a MOSFET. This is the applications, is the MOSFET you can use for the inverter. Inverter as a UPS, uninterrupted power supply, you can use for the inverter. It's a backup for the energy. Then digital circuit, this is also digital circuit you can use for the all digital circuitry, like gates, AND gate, NAND gate, NOT gate, universal gate, then special gate. All are the digital circuits you can use for the multiplexer, demultiplexer for MOSFET. Very large scale integration circuits, it is a MOSFET. And last one, it is a high frequency amplifier. High frequency amplifier, I am speaking loudly, very loudly, very loudly, because my voice is clearly here for the 10 kilometer or 5 kilometer distance. That's why MOSFET you can use for the 5 meter or the 1 kilometer. 1 kilometer is the greater than 1 kilometer distance. I am speak loudly. The voice is generating for the high frequency amplifier. Then this is the IC. You can see 555 timer IC for the printed circuit board PCB designing. There are the 8-pin IC. Left side is the 4 pins and the right side is the 4 pin. Integrated circuit package. IC is the integrated circuit packages. Here the single pin IC. This is the single pin, SIP, single inputs packages. But here double inputs because it's a maximum inputs. Dual inputs you can use for the base is required dual input packages. And this type of the packages you can use for the microelectronics, electronic capacitor, throw, single throw, double throw. It is mounted PCB base is required. Also you can use for the PCB printed circuit boards in a electronic circuitry like the telephone, LED screen, monitor, CPU, refrigerator, washing machines, ovens, mixers. These are all types of the electronic circuits like sounds you can use for the IC packages. This is the all our IC packages. Here the quad IC, quad input. Here the double pin. Double means here right side is the 10 pin, another side is the 10 pin. Left side is the 8 pin, another side is the 8 pin. But the quad you can use for the 40 pin IC for microcontroller. 300 pin IC, that is meaning for the very large scale integrated circuit like a Xilinx IC. That type of the packages like a formation of microprocessor, microcontroller and higher read counts in the dual input packages. Dual input packages you can use for the controller for controlling the whole circuitry. That is here completed the first unit. You can write down the conclusion. First unit, first experiment, study of resistor and the capacitor. You can use for the active components and the passive components. In this experiment, we can learn active components like a BJT, MOSFET, diode, BJT, MOSFET, IC switches. And we can learn in a passive component. We can learn resistor, capacitor, inductor, switches, transformer, connectors. All are the passive components. Okay, students, any queries regarding the first experiments? Okay, thank you all. Here I am stopped. Any queries regarding first unit? First experiment, active passive components.
No, ma'am.